This is Algebra 2, Lesson 107 on page 440. Okay. The title of this lesson is Numbers and Their Value. Numbers and Their Value, page 440. The value of a digit, of a single digit, is determined by its position in the number. The value of a digit is determined by its position in the number. So I'm going to write a number on the board. What's the value of the sevens digit? It's in the tens place, right? It's in the tens place, so its value is 10 sevens. Got it? Make sense? And the value of the 2, it's in the 1. It's in the units place, right? So really, I could write this as 7 times 10 plus 2 times 1. Couldn't I?
I feel like this is going to be one of those lessons that is absolutely pointless and you never use it in your life.
Or I could have written this as the number, the tens digit times 10 plus the units digit times 1. You see that? The tens digit times 10 and the units digit times 1 equals the number. That's the number. Do you agree with that? Everybody agree? Okay. Now, what if the digits are reversed? If I tell you I'm going to take 72 and reverse the digits, what number do I have then? I have 27. Now, the units digit has been placed in what position? The units digit has been placed in the tens position, right? And the tens digit has been placed in the units position. That's what equals the number reversed. Got it? When we reverse the number, we're taking that units digit and multiplying it by 10, and we're taking the tens digit and multiplying it by 1. Make sense? All right, so here are really 2 equations you need for this lesson. You need to know that the value of a number is the tens digit times 10 plus the units digit times 1. But if we choose to reverse the numbers, then I'm putting the units digit in the tens place and I'm putting the tens digit in the ones place. Make sense?
It tells you like when it's reversed.
When you hear when the digits are reversed, or when the when the numbers are reversed.
Basically.
Yes, you had a question?
Yeah. Can you do this with hundreds and thousands or not? Only.
It will only be with tens and ones.
Where do you?
If I go to hundreds, then I need 3 equations. They're only going to give you 2 equations. When I have 2 variables, I need 2 equations. When I have 3 variables, I need 3 equations. So could I do it? Yes, we can. The textbook is not going to do it. You're only going to have tens and ones.
Do you use this in math or not? Of course.
The close, no. Do you use it in logic? And on the ACT? Yes.
Okay.
Yes. So really this lesson is, can you take words and can you make up an equation? I mean, just yesterday I was tutoring a kid for the ACT, and 100% it was two linear equations that you had to come up with. And you solve for one of the variables. Nobody thinks about that on the ACT. So you do have to be able to take words and write linear equations and solve for one of the variables. So do I see this? Yes. In logic and on the ACT. Make sense? Okay, now look at example 1. It's the best way to do it is to walk through the examples. Sadly, there are only 2. But literally, it is those. I have more examples. Those 2 equations, other than one which is an obvious. Okay, there's one more equation, but it's an obvious. All right, look at example 1. All right, it says the sum of the digits. What am I adding? The digits. What are the digits represented by?
T plus U.
T plus U. That's correct. The sum of the digits in a 2-digit counting number is 11. That means if I add the tens digit and I add the units digit, the sum of those is going to be 11. It could be 8 and 3. It could not be 1 and 10, obviously. It could be 9 and 2. It could be 7 and 4, 6 and 5. You get it? Make sense? All right. If the digits are reversed, what happens when the digits are reversed? I'm multiplying 10 by the units digit and 1 by the tens digit. All right, if the units are reversed, this new number, this represents the new number. This is digits reversed and new number. The new number is 27 greater than the original number. What's the original number?
10T plus 1 register U.
Correct. That's the original number. All right, so this is digits reversed. It's the new number. This is the original number. Got it? All right? So how would we solve this? We want to know what the number is. What would you do?
Could you do substitution?
100% substitution. So what would you substitute?
T or U?
T or U? Which one? Make a choice.
T.
T equals 11 minus U. Right? All right, before I substitute that in for T, I just want to get my T's together and I want to get my U's together. All right, so I'm going to subtract T on both sides. And I'll subtract U on both sides. Just get all my T's and all my U's together. Got it? So I end up with 9U, Paula, not 6. 9U equals 9T plus 27. Now I'm going to substitute this in for U. Everybody with me? All right, so 9U is 9 times 11 minus U plus 27. All right, so 9U, distributing that 9, it's 99 minus 9U plus 27. I'll add the 9U to both sides. So we'll add 9U. 99 and 27 is what? 126. Is that 126? 18U. What's that divided by 18?
7.
Is U 7? Everybody agree? If U is 7, what's T? 4. What's the number? The tens digit
47.
and the units digit. 47. That's the number. Make sense? Got it? All right, let's do the next example. Example 2. I also have a few more examples. All right, the sum of the digits of a 2-digit counting number was 9. All right, Alexis, what do I write? The sum of the digits of a 2-digit counting number was 9.
T plus U.
Yes. All right, Jim, what do I write when the digits were reversed, the new number?
1, 2 plus 10U.
That's the digits reversed. The next word is was. What do I write?
Equal.
Equal. Was. 45 less. What do I write?
Minus 45.
I'm going to write it over here because it's 45 less than something. All right, Paul, what do I write? Then the original number.
Good question. I think I lost a mile back.
Then the original number. What's the original number? Yes.
9?
Huh? What will represent the original number? Yes, Luke.
Oh.
10t plus 1u. Okay, those of you not taking notes are going to be very sad next year. Very sad. And I will probably call you out on it and say how disrespectful you're being by not thinking what I say is important. All right, so now what do we want to solve for first, T or U? Just tell me. Megan, make a choice. What do we want to substitute in? T. So we want to say T equals 9 minus U? Or, yeah. So T equals 9 minus U. First, I want to combine my T's. So I'm going to subtract T from both sides. I'll subtract U from both sides. So I'm left with 9U equals 9T minus 45. Now, for T, I'm going to substitute 9 minus U. All right, so I have 9U equals 9 times 9 minus U minus 45. This is simple algebra. Actually, it's not even difficult algebra. Distribution 81 minus 9U minus 45. The pattern always looks like this. There's always 9s in the number. Always. There's always 9s. If you don't see 9s, you've done something wrong. All right, so then we have 18U is what's?
36.
36, thank you. Dividing by, if you get a negative number, you have done something wrong because there's not going to be a negative digit. All right, my units number is 2. If my unit number is 2, what's my tens number?
7.
So what's the number?
72.
72. Okay, now you're going to have to listen carefully. All right, so these feel a little different. All right, but they're very similar. You ready? You just have to listen really good. Let's write the equations. These are going to feel a little different, but this is from a different Algebra 2 class. The sum of the digits in a 2-digit number is 7. The sum of the digits in a 2-digit number is 7. What do I write?
U plus T equals 7.
Got it? Okay, you're going to have to listen closely. If the tens digit, what do I write? If the tens digit.
10.
T for 10. If the tens digit is, what do I write?
Equals.
Is 3 less than the ones digit. 3 less
Oh, it's,
than the ones digit.
U minus 1, or 3.
What's the digit? Okay, so you could find that, right? Okay, that's easier than our, right? This is a different Algebra 2 class. This is what they do. Easier than ours. Yes.
Is it the same book or?
No. It's a different Algebra 2 class. All right, then they get maybe not harder. They're all like that. The tens digit, 5 less than the ones digit. The tens digit, 2 less than the ones digit. Here we go. The sum of the digits in a 2-digit number is 13. Sum of the digits in a 2-digit number is 13. If the digits of the number are reversed, what do I write? Digits of the number reversed. 10u plus 1t. That's reversed. That new number is 9 more. It is 9 more than the original number. What's the original number?
10t plus 1.
Yes. And you could solve that, right? All right, let's solve it. What are we gonna, what do you want to solve for here? Which one?
T equals 13 minus u.
Okay. Now I'm going to combine my t's. I'll subtract t, I'll subtract u. So I have 9u equals 9t plus 9. So then for t, we'll substitute in 13 minus u. What's 9 times 13? 1 what?
117.
17 minus 9u plus 9. So we'll add the 9u on both sides. So we have 18u is 117 and 9 is 126. Didn't we just have this?
I feel like we did.
Divided by 18. What was that?
7.
Is it 7?
Yes.
All right, but now they add up to 13. So what's the number?
6.
67. Yes, 67.